Hi everyone, welcome to Vedantu NEET English. How are you all? Very good evening to everyone here. Very good evening. So let me see why students have not joined till now. Why students have not joined? So let me drop a text. So guys, it's so cold here. It's so cold here. Firstly, Happy New Year, everyone. Happy New Year, all the students. May this year brings lots of prosperity, happiness in your life. I wish all the, I wish everything that you deserve, you will get in this year. Right? Very good evening, Bacho. Very good evening. Happy New Year to everyone here. So I really hope so. In 2024, in 2024, December 31, you will celebrate this with your friends like the way you always wanted to celebrate in your MBBS college, in your dream college. I really wish you get your dream college this year. Are you all excited for that? So guys, what's your New Year resolution? So let me see, what's your New Year resolution? Ma'am, why are you wearing specs? Because guys, without specs, I am unable to see. That's why I have to wear specs. Otherwise, my eyes get really tiring after the class. There's so many lights and this display boards, that gets very hectic. That gets very uncomfortable for my eyes. Yeah, and I need to protect my eyes. So that's why I'm wearing these spectacles. Okay. Yes. Happy New Year, Happy New Year, Happy New Year. So what are your New Year resolution, everyone? What are your New Year resolutions? Everyone in the chat box. Perfect. To fix my basics of organic. Perfect. Daily yoga and exercise. Perfect. To work twice as harder as last year. Very good. So inspiring. So inspiring, all of you. NEET aspirants to achiever. Perfect. Very nice. NEET aspirant to a NEET achiever. And an inspiration to all the NEET aspirants, right? My resolution is to become spiritual. Perfect. Very nice. Consistently, ma'am. Now, perfect. Consistency, to maintain the consistency. And what about other 26 watching here? Why are you not telling me? What are your New Year resolutions? I'll be consistent. Perfect, perfect, perfect. Any other New Year resolution? Any other New Year resolution? To prepare for NEET religiously, to attend all the classes, do the homework and do my self-study along with that, right? That must be your New Year resolution. To get a dream medical college, very nice. You will surely get it. If you're doing hard work in these 4 months, you will surely get your dream college. You will surely get your dream college. One thing that you need to do is hard work, like discipline, consistency. These are the things that will make you what you always wanted to be, right? Okay. Okay, to crack NEET mem. Perfect. So it seems like all of you have the same goal, right? All of you have the same goal to crack NEET, to achieve that thing that you have always dreamed of, and you will achieve that if you are doing that hard work, right? Okay. So now let us start the session. At the wasted 11th, at least utilize 12th by using this channel. Perfect, Yashwat. You will never be disappointed. And I assure you that you will never be disappointed, right? You will clear all your basic if you are consistent. Yes. Very nice. Very nice. So guys, let us jump to this session. So today we are going to do hyperconjugation electromeric effect. So are you all excited? This is a very nice topic, very easy topic, very interesting topic. You will have fun doing this topic. You will really love it. Hyperconjugation is something very easy and interesting, and questions are asked this way. Right? Okay, perfect. Perfect, perfect. So let us start. First is hyperconjugation. So what are the other names of hyperconjugation? The other names of hyperconjugation are low bond resonance, anchimeric effect, and then there is Baker-Nathan effect. So Baker-Nathan effects comes from the name of scientist, right? This is the name of scientist Baker-Nathan. So, and about no bond resonance and enchimeric effect. Why we name hyperconjugation as no bond resonance and enchimeric effect? We'll find out when we will be solving the question based on hyperconjugation. So let us firstly understand what do we understand by hyperconjugation. What do we understand by hyperconjugation? Let us firstly understand that. So basically, if we talk about hyperconjugation, there are two conditions of hyperconjugation. First is alpha carbon should be sp3 hybridized. Okay, so do you all know what is sp2, what is what is sp3? As I told you before also, I am telling you again also. So guys, if you have sigma bond plus lone pair, sigma bond plus lone pair equals to 4 or 3 or 2. When sigma bond plus lone pair equals to 4, then this is sp3 hybridization. When sigma bond plus lone pair are equals to 3, then that is sp2 hybridization. If sigma bond and lone pair is equals to 2, then that is sp hybridization. Okay, so this is the sequence that you need to know. What is sp3, what is sp2, and what is sp hybridization, right? So now if we take this example, this is C double bond O and this is the carbon, this is the carbon. Now you have, this is the main group, this is your main group, right? And this, the carbon attached to the main group is called the alpha carbon, and the carbon attached next to alpha carbon is called beta carbon. So this is alpha carbon and this is your beta carbon. This is also alpha carbon, the carbon next to attached is beta carbon, right? So do you all understand what is alpha carbon, what is beta carbon, what is sp3, what is sp2, what is sp? Understood everyone? What do we understand by these statements? Understood everyone? Right? Okay. So guys, also like the session in between. Okay, like the session side by side. So let me see how many students are there. There are 30 students watching and there are 22 likes. Oh, that's so sad. You are actually, like Gopika ma'am says, actually very confused. Very confused you are. Okay. Yes. Okay, perfect. So now let us see, this is alpha carbon, this is beta carbon. Now what is the condition? The alpha carbon should be sp3 hybridized. That means this carbon, this alpha carbon should be sp3 hybridized. If this carbon is not sp3 hybridized, then hyperconjugation will not occur. Now second condition is the alpha carbon should have at least one hydrogen. There should be at least one hydrogen attached to alpha carbon, right? These are the two conditions. Only then hyperconjugation will occur. Otherwise, there will be no hyperconjugation, right? So firstly, let us see some of the examples. Let us see some of the examples to understand this better. To understand this better, let us see the examples. For example, you have C double bond O. Actually, hyperconjugation doesn't occur here. Let us see. For example, you have C positive and you have C double bond C. Now tell me if the hyperconjugation will be present here or not. If the hyperconjugation will be present here or not. This is your main group. This is your main group. This is your main group, right? Because this is the carbocation. This is the main thing that you need to focus on. And the carbon attached to the main thing is called alpha carbon and next to it will be beta carbon. Alpha carbon is sp2 hybridized. This is sp2 hybridized, and that is the reason hyperconjugation will not take place here. Okay, hyperconjugation will not take place here. Yes, I'll definitely take hydrocarbons. I'll definitely take that. Perfect. So now let us jump to the conditions. Next conditions. So firstly, we have understood the condition, that is alpha carbon should be sp3 and at least one alpha hydrogen should be present there. Next is, what are the intermediates where hyperconjugation takes place? So first we are going to discuss is carbocation, then we are going to discuss free radical, then we are going to discuss alkene. These are the three things that we are going to discuss, right? So is everyone ready for that? we are going to discuss these three things: carbocation, free radical, and alkenes. These three things we are going to discuss. Now, let us understand with the help of a diagram first, with the help of a structure, right? First is carbocation. What is a carbocation? So, for example, you have this thing. You have CH3Cl, right? As chlorine is more electronegative, so it will be, the electrons will be more towards chlorine than towards carbon, right? So what will happen when the bond will break? This chlorine will take the electrons with itself, right? These two electrons that were covalently bonded firstly, the chlorine will take those electrons, right? And here will be a positive charge. Why here will be a positive charge? What is the reason? The reason is vacant p orbitals. Is there actually a positive charge? No, there is not actually a positive charge in reality present there. There is a p orbital which do not have any electrons. Okay, this positive charge means there is a p orbital which has no, this is a vacant p orbitals. That means it is a carbocation. So carbocation positive symbolizes that there is the presence of vacant p orbital here. Okay, right? So now let us see how will it show hyperconjugation, right? So you have this carbon will be bonded to three hydrogens, and this is bonded to one p orbital also. Not bonded to, it has one positive charge. This means, wait, just a minute, it's not be like this. It will be like this. Okay, it will be like this. This thing will not show any hyperconjugation. This carbocation will not show any hyperconjugation. What is the reason? Why I have erased this? The reason is, this is the main thing, and it does not have any alpha carbon only. If it doesn't have any alpha carbon, then what's the point of hyperconjugation? The conditions for hyperconjugation is there should be an alpha carbon, that is sp3 hybridized, and that is having at least one alpha hydrogen. That is the condition. So it does not have any alpha carbon. That is why this will not show any hyperconjugation, right? Okay. So now let us see hyperconjugation here. How will this happen, right? So as you all know, this means there is one vacant p orbital. So guys, everyone, students, tell me what will be the overlapping here. How will the overlapping occur here? So what will happen here? This carbon number, this carbon has one p orbital, has one vacant p orbital. And this carbon has sp3 hybridized, and this 1s. This hydrogen has 1s orbital. This has one sp3 hybridized orbital. So these will overlap. So what will happen here? These two electrons will move here. These two electrons of this sigma bond, the two electrons of this sigma bond will overlap with this vacant p orbital, and that is how no bond resonance will occur. That is how no bond resonance will occur. We'll see why it is called no bond resonance. Let us see. So now the overlapping here will be sigma to vacant p orbital. Overlapping. The overlapping here will be sigma. The sigma is this, either this or either this, right? Any of these sigma bonds and the vacant p orbital of this carbon atom. The overlapping will be between sigma, vacant p orbital overlapping. Understood, everyone? This will be the overlapping here. Understood? Right? Right? Understood, guys? Tell me. Understood? Yes. Don't call me sir. I am ma'am. I know I have cut my hair too short, but that doesn't mean I have changed my gender. Okay? So this is sigma vacant p orbital overlapping. So now let us see how the overlapping happens here. So see, this is the example how the structures are formed, right? This is C, this is H, and this is positive. So what will happen? The two electrons here will get shifted here. This will be shifted here. This will be shifted here. Let me draw this with some other pen. So these will be shifted here. The two electrons between C and H sigma bond will be shifted here, and this will form a pi bond because of the overlapping between sigma and vacant p orbital of this carbon, right? Because of these overlapping, these electron will shift here, and then what will happen here? What will happen here? The structures will be, this will be H positive, because now this hydrogen do not have any electrons. So this will be H positive, this is H, and this is double bond C, and this is H, and this is also H. Okay, see, this is H2, right? This is H, and this is also H. This will be the hyperconjugation. And why it is called no bond resonance? The reason is because here you can see there will be H positive present here. This will be attracted to this. It will not change its place. This hydrogen, even though it is not bonded to this carbon now they don't have actual bond between this carbon and this hydrogen, but still this hydrogen will not change its place. That is why it is called no bond resonance. There will be no bond between this and this, but still there will be this hydrogen will be present here, right? This is called, that is why this is called no bond resonance. And why it is called Ankimeric effect? Ankimeric means neighboring effect. So this neighbor is helping this carbon to complete its vacancy, to complete its electron deficiency, and that is why it is called Ankimeric effect. That is why it is called Ankimeric effect. Okay, yes, this is very simple, the most simple effect. I am telling you the most simple effect, right? So guys, let us see. This is the first structure, and after that let us see how many structures will be formed. How many structures? So this hydrogen can do the hyperconjugation. This hydrogen can also do the hyperconjugation in the same manner, and this hydrogen can also do the hyperconjugation in the same manner. That means the number of alpha hydrogen tells us the number of hyperconjugating structures, right? So there can be also a structure like this. There can also be a structure like this. Okay, there can also be a structure like this. There can also, this is the second hyperconjugation structure, and the third hyperconjugation structure will be, this. These are the three hyperconjugation structures that it can be drawn, right? Three hyperconjugation structures in total. Okay, so from this, can we say that the number of alpha hydrogen is equals to number of hyperconjugating structure? Am I right with this? Ma'am, please, one more example. Okay, one more example. There are lots of examples that you will do today. See what happened. I can explain you this again also. So what happens here? The bond between this carbon and this hydrogen breaks, and due to the overlapping of this sigma bond between this CH and the vacant p orbitals of this carbon, the overlapping of these two things, there will be a pi bond between these two carbon due to that overlapping. And the electrons between this carbon and hydrogen, these electrons will jump and form a pi bond here, right? Now this hydrogen will not have any electrons, right? So actual structure will be this. I can draw the three structures here. I can draw all the three structures here. If this hydrogen number 1 is separating, so what will happen? The structure number 1 will be hydrogen, H positive, double bond, C, and this is hydrogen, The structure number 2 will be, if this hydrogen is showing hyperconjugation, what will happen? This carbon, this hydrogen, this H positive, this will be double bond, CH, and this is H. If this carbon is showing hyperconjugation, what will happen here? This carbon and yes, this hydrogen, this is the H positive, double bond, C, this is H, right? Understood, guys? Right? Yes. Okay, perfect. So these are the three hyperconjugation structures. So now let us see, okay, the stability and hyperconjugation. Why we are studying hyperconjugation? Because in the end we have to study the stability of intermediates. And for that, more is the hyperconjugation structure. More are the number of hyperconjugation structure. More will be the stability of that intermediate. Right? Okay. So, how will you calculate the number of hyperconjugation structure? Simply calculate the number of alpha hydrogens present. Then, the number of alpha hydrogen will be the number of hyperconjugation structure, and more the number of hyperconjugation structure, more will be the stability. Okay, you just need to calculate the number of alpha hydrogens there. Right? Okay. Okay, perfect. Now, next is practice questions. Let us do some practice questions here. Let us do some practice questions here. So, the first practice question, A and B. Firstly, tell me, this A1, this A, will this show alpha, will this show hyperconjugation structure? You need to identify two things. Is there any alpha carbon present? Is there any alpha carbon present? You will see there will be 3 alpha carbon present here. This structure can be written as, this structure can be written as this. This structure can be written like this, right? This structure can be written like this. So, here in this structure, we have 3 alpha carbons. We have 3 alpha carbons. All 3 alpha carbons are sp3 hybridized. That means the first condition is satisfied here. Now let us come to the second condition. The alpha carbon should have at least one alpha hydrogen. So it has not only one, it has 3 alpha hydrogen. It has 3 alpha hydrogen. 3 alpha hydrogen. So total number of alpha hydrogen are 3 plus 3 plus 3, that are 9 alpha hydrogen. And the number of alpha hydrogen are the number of hyperconjugation structure. So there will be 9 hyperconjugation structures. Understood? There will be 9 alpha hydrogen and 9 hyperconjugation structure present here. Right? Okay. Now, next is, what is the answer of B? How many alpha hydrogen are present in B? How many alpha hydrogens are present in B? How many alpha hydrogens? As you can see, this is the main carbon. This is the main focus point. Okay, this is alpha. This is alpha. This is beta and this is also beta. You don't need to focus on any beta carbon. You will have to focus on only alpha carbon. So this alpha carbon is sp3 hybridized, right? This is also sp3 hybridized. So if alpha carbon is sp3 hybridized and moreover sp3 hybridized, second condition is it should have at least one alpha hydrogen present there. So this also has one alpha hydrogen. This also has one alpha hydrogen. Total 2 alpha hydrogen, and this will be the number of hyperconjugation structures. So we have 2 hyperconjugation structures, right? Okay, perfect. Moving to next. This is A, this is B, and this is C. Now tell me, what are the number of alpha hydrogens present here? What are the number of alpha hydrogens present here? Perfect, very nice. 2 structure is possible, very nice, very nice. So let us understand this. This is your carbocation. This is the vacant orbital. This is the vacant p orbital. The carbon attached to this point is called alpha. This is also alpha, right? How many alpha hydrogens are present here? You all know in these kind of structure, it's not provided, the number of hydrogen are not written in these kind of condensed structures. So, right? So, this means this carbon has 2 hydrogen to complete the valency. This has 2 hydrogen to complete the valency. This is alpha, this is alpha. So, total we have 1, 2, 3, 4 alpha hydrogen. That means 4 hyperconjugation structures. Now, let us come to this point. Now, tell me, will this structure show any hyperconjugation structure or not? Perfect, very nice. Will this structure show any hyperconjugation structure or not? Will there be any hyperconjugation structure? There will not be any hyperconjugation structure present here. What is the reason? This alpha carbon, this is the alpha carbon. The alpha carbon is sp2 hybridized, right? And this condition is not satisfied. The alpha carbon should be sp3 hybridized. Only then hyperconjugation will occur. So this will not show any hyperconjugation structure. Right? Okay. So now let us jump to third question. C part. So the answer to C part. What is the answer to C part? How many hyperconjugation structure are present here? How many hyperconjugation structure are present here? So this is the vacant p orbital. This is the carbocation. Your main focus point is this. The carbon attached next to it is alpha. This is alpha. But this alpha is sp2 hybridized. And this alpha carbon is sp3 hybridized. And this has 2 hydrogen. This will be to complete the valency. This will have 2 hydrogen attached to it. So the number of alpha hydrogen will be 2 alpha hydrogen. And that will be the number of hyperconjugation structures. And that will be the number of hyperconjugation structure. Clear everyone? Is this clear to everyone? 2 hyperconjugation structures. Very nice, very nice, very nice. Let us do this again. If I have to draw the stability order of this, what will be the stability order of this? What will be the stability order? The stability order will be, the more the number of alpha hydrogen, more will be the stability. A, then C, then B. This will be the stability order. This will be the stability order of these structures. Okay? Yeah, it's so cool. Yeah, it's so cool. It's actually very cool. Now, tell me, this is B, this is C, and this is D. A, B, C, D. Now, let us identify the number of alpha hydrogens. Firstly, those will be the number of hyperconjugation structure only. So, I'll directly write this much hyperconjugation structure. In place of alpha hydrogen, I'll write hyperconjugation structures. Okay, so this is the carbocation. This is alpha, this is alpha, this is alpha. Okay. It has 3 hydrogen, it has 2 hydrogen, it has 2 hydrogen. Total will be 3, 4, 5, 6, 7 hyperconjugation structures. Here you will have this alpha carbon, and this alpha carbon is sp3 hybridized, but this alpha carbon has only 1 alpha hydrogen. So this will be 1 hyperconjugation structure. Right? Going to this, coming to this. This is the alpha carbon, this is alpha carbon. This alpha carbon is sp2 hybridized. This alpha carbon is sp2 hybridized, so we will not take this into account. Let us come to this alpha carbon. This alpha carbon will have 3 hydrogen attached to it. So this will be 3 hyperconjugation structures. Right? This will be 3 hyperconjugation structures. Now, what about D? This is the positive charge, and the carbon next to positive charge is alpha carbon. But this alpha carbon is sp2 hybridized. That is why it will have no hyperconjugation structure. So what will be the order? What will be the order? Guys, what will be the correct order of stability? A, as it has maximum number of hyperconjugation structure, then C, then B, and then D. This will be the right order of stability. Understood? A, C, B, D. This will be the right order of stability. Yes, very good. 7, 1, 3, 0. Very good. Very nice, very nice. Now, this was about carbocation. Now let us understand what about free radical. What do you mean by free radical? Free radical means it has p orbital, but that p orbital is not vacant. It has 1 electron in it. Okay, this has 1 electron in it. It is half filled p orbital. Right? This is half filled p orbital. So now what will happen here? The overlapping will be, this will be carbon, this will be carbon. This carbon will have, wait. This will be carbon, this will be carbon. This carbon will have a p orbital that is half filled. And this carbon will have three hydrogens attached to it. That will be sp3, and this is 1s. This will be again sp3, and this is 1s, and this will again be sp3, and this is 1. This is hydrogen, 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 right? And there will be bonding. There will be a sigma bond between this, right? So there will also be this carbon will be sp2 hybridized, and this will be 1s. sp2 hybridized, and this will be 1s. Understood, right? So let us see what will happen here. What will happen here? So what will happen? This one electron, this hydrogen will give away. This hydrogen will give its one electron to this carbon, right? The overlapping will happen between the sigma bond of CH, the sigma bond of CH, and the half-filled orbital of this carbon. There will be overlapping between the sigma bond of this CH, and the electron will be shifted here, right? So there will be overlapping between sigma, half-filled, p orbital overlapping. So this is important. You need to know what is the where is the overlapping happening, right? The overlapping will be between sigma, half-filled p orbital overlapping. Okay, sigma, half-filled p orbital overlapping. Perfect, very nice. Yes, there will be homolytic cleavage. Homolytic means one electron will be here only, one electron will be shifted here. When there are two electrons that are getting shifting, that is heterolytic cleavage. But when there is only one transfer of one electron from a bond, that is called homolytic cleavage. Yes. Yes, hydrogen is very sour. Hydrogen is very innocent. And he gives away its electrons. A very small, little, so cute, innocent baby who gives off its electron to other people. So he's that kind of person, right? Okay, very kind, very kind. Okay, so now let us understand how the hyperconjugation occurs. How is the hyperconjugation occurring here? So let us see. This is the carbon, this is hydrogen, this is hydrogen, this is hydrogen, and this is carbon, and this is hydrogen, and this is hydrogen. And there is one dot. This dot means one electron, right? So what will happen here? There will be homolytic cleavage. This electron will get shifted here, and this electron will be shifted here, right? And this one electron will be here. So what will happen? What will happen? What kind of cleavage is happening here? There is homolytic cleavage. There is homolytic cleavage. So this will be one hydrogen. This will be hydrogen dot. This will be double bond. This is H and this is H. So what happens? The only difference between carbocation and free radical is that we consider these two intermediates as electron deficient only. The only difference between these two intermediates is that this intermediate, in this we say in carbocation we write it as positive, and here we write it as a dot, a simple dot. Okay, right? Yes. How many structures are possible here? Here are 3 alpha carbons, so the structure here will be 3 alpha hydrogen. The structure will be 3 hyperconjugating structures will be possible in this case. I can also draw it for you. The structures will be this carbon, this hydrogen, this will be alone, this will be left alone, and this will be double bond. This is H and this is H. Another hyperconjugating structure will be this hydrogen, and now this will be left alone, and this is hydrogen, and this is hydrogen. So these are the 3 hyperconjugation structures that will be taking place here. Okay? Yes? Understood? Everyone? Understood this? Got this? Yes. Now, let us see the practice question for this. What is the practice session for this? So this is the first A part. This is the first practice session. This is the first practice session. Yes. Now, tell me, it's in a very simple manner. You just need to calculate the number of alpha hydrogens here, right? So this is the focus point here. This is alpha carbon. This is alpha carbon. These two alpha carbons are sp3 hybridized only. These three alpha carbons are sp3 hybridized only. Okay, so this will have two hydrogen, this will have no hydrogen, this will have no hydrogen, right? So there will be two hyperconjugation structures. And in the B part, this is the alpha, this is the alpha. This is sp2, so no hyperconjugation structure from this side. This is sp3, but this has only one alpha hydrogen, so this is one hyperconjugation structure, right? Okay, this is one hyperconjugation structure. This is the main point, and you have this alpha, you have this alpha. This is sp2 hybridized. Just give me a minute, students. Just give me a minute. This is alpha, this is alpha. This is sp2. So, no hyperconjugation conjugation structure from this side. The hyperconjugation structure here will be, there is just one alpha hydrogen. So, the hyperconjugation structure is 1. Right? There is one hyperconjugation structure. Now, this is also alpha. This is also alpha. Both are sp3 hybridized. This has 3 hydrogens and this has only 1 hydrogen. So total number of alpha hydrogen is 4. That is the amount of hyperconjugation structures. So the total structures are 2 here, 1 here, 1 here and 4 here. Right? Understood? Okay, understood? We can't tell the stability between B and C. Which is more stable? We can't say. If someone is asking you which is more stable, we can't say, we have no idea what will be the stability of hyperconjugation structure of B and C if we consider only hyperconjugation effect here. There are other factors. There is back bonding. So many factors present here. Inductive effect. We'll study it when we'll study the stability of intermediates. When we will study the stability of intermediates with all the effects like inductive effect, hyperconjugation, aromatic, back bonding, resonance. We'll add up all those effects and understand the stability of intermediate. Okay, only then you will be able to find out the stability between B and C. Otherwise, on the basis of hyperconjugation, that's not possible. Okay? Yes. Same. I know you will ask this, so I have already answered that. You won't be able to find the stability of B and C if we consider only hyperconjugation structure. Right? Okay? Okay? How first is 2? So guys, let us see. This is alpha, right? So this alpha carbon is already attached to 2 methyl groups in this carbon and this carbon. That means this alpha do not have any hydrogen present here. So there will be no alpha hydrogen, right? And this alpha has only I've written it wrong. 1, 2, 3. Wow, bacha, wow. This is 1 alpha. There will be 1 hyperconjugation structure. Wait. Yes. There will be 1 hyperconjugation structure. Very good. Very good. There will be 1 hyperconjugation structure. Yes. I did a mistake there. There will be 1 hyperconjugation structure. Yes, very good. Who identified this? Yashwant. Very good, Yashwant. Very good, Yashwant. Very nice. Yes, I like these kind of students who just don't blindly follow things. They also, try to be active, more active. Ma'am, 3, please check. Let me see. This is sp2. Yeah. Third, we have 1 hyperconjugation structure only because this alpha is sp2 and this alpha is sp3 and 3 are already bonded to this and it will have only 1 alpha hydrogen. So 1 hyperconjugation structure. Okay. Ma'am, how 1? That's what I have asked, ma'am. That's what I have asked, ma'am. So are you clear now, Yashwant? Is this clear to you? So guys, see. This is the alpha carbon. This is the alpha carbon. Right? So this alpha carbon is bonded to 1, 2, 3 group before also. So the tetravalency of carbon is completed. That is why no hydrogen is linked here. And this is also sp3. But here the 1 valency of carbon is left. right? So it will be completed by one hydrogen atom. So there is only one hydrogen atom, only one alpha hydrogen. So that is why one alpha hydrogen is there. That is why one hyperconjugation structure. Understood, Sar? Understood? Sharat. Sorry, फिर ये बोलेगा. Then he'll say again, ma'am, it's not Sarat, it's Sharat. Yes, Sharat. Understood now? Why it is one? Understood? Understood? Yes? Okay, perfect. Now, let us see alkene. How will you identify the hyperconjugation structure of alkene? So, alkene is double bond. This is double bond. So, tell me, this is carbon number 1, this is carbon number 2, this is carbon number 3. Which is the alpha carbon here? Which is the alpha carbon here? Carbon number 1, 2 or 3. Which carbon is the alpha carbon? Which carbon is the alpha carbon here? 1, 2 or 3. Which is the alpha carbon? Tell me. Which is the alpha carbon? Yes. Very nice. Very nice. Which is the alpha carbon here? Alpha carbon here is 2. Very good. So you need to understand firstly one thing. This is the main group here, and the carbon attached adjacent to the main group is called alpha, and adjacent to it is called beta. And the carbon attached adjacent to alpha carbon is called beta carbon. Okay? Okay? Understood? So this is the alpha carbon. So that's all I need to tell you. Hence, let us see what kind of bonding is happening here. So this is the alpha carbon. It has one H here, right? One H here. This is C, double bond C, right? So now this is C. Okay. Now let us see. The bonding will be, the overlapping will be between the sigma bond of the CH and the orbital present here. Now the question is, which orbital will be present here? Which orbital will be present here? The orbital that is present here is what is happening here? There is a, as you have already studied that in MOT, molecular orbital theory, you have already studied that in molecular orbital theory, you have bonding orbital, you have anti-bonding orbital, right? So, anti-bonding orbital here will be vacant. So, write it as the bonding will be between, overlapping will be between sigma pi star. This pi star means anti-bonding. The sigma pi star vacant pi star. Or can you write it as sigma vacant pi star anti-bonding. Overlapping, right? The overlapping will be between the sigma bond and pi star anti-bonding orbital of this pi bond. Okay? Okay? Yes. Very nice. Very nice. Very nice. So this is the overlapping. So now let us directly jump to the question here. Let us jump to the question here. This is the A part, this is the B part, and this is the C part. This is the A part, this is the B part, and this is the C part. Let us see how to identify the alpha hydrogens here. Let us see, this is the main group present. This is the alpha carbon, this will be the alpha carbon, right? So it has, this alpha carbon has 3 hydrogens. This has 3 hydrogens. So total we have 6 hyperconjugation structures. In B part, you have, this is the main group. This is alpha carbon, this is alpha carbon. So there are 2 alpha carbons. Both are sp, 3 hybridized. Both are sp, 3 hybridized. Right. Okay. So now, this also has 3 carbons, 3 hydrogens. This has 2 hydrogens. Right. So total will be 5 hyperconjugation structure. There will be total 5 hyperconjugation structure present here. Yes, very nice. 5 structures present, not 6. There will be 5 because this has only 2 hydrogens. This has 3 and this has 2 hydrogens. And there will be 5 hyperconjugation structures. So what about C? How many hyperconjugation structures will be present here? This is the main group. This is the main group. This is the alpha carbon. This is the alpha carbon. This alpha carbon is already attached to 3 other atoms. Now, there is just one hydrogen present here. There is one hydrogen present here. So, there will be in total 2 hyperconjugation structures. Understood? 2 hyperconjugation structures are present in C. Right? So, what will be the order? The order here will be, the stability order here will be A, then B, then C. This will be the stability order of these structures. Okay? Very nice. Very nice. Very nice. Very nice. Okay. Now, let us see the next question. This is A and this is B. Tell me which of this is more stable? Which of these is more stable? Out of these, which is more stable? This is A, this is B. Identify the alpha carbon firstly. This is the main group. This is alpha. This is alpha. This alpha is sp3. This alpha is sp3. There are only 2 hydrogens present here. There are only 2 hydrogens present here. In total, it has 4 alpha hydrogen. That means 4 hyperconjugation structures here. Right? And about this structure, you have this double bond present here. This is the double bond. This is the alpha. This is alpha. This is alpha. This is alpha. This alpha has 3. This alpha has 3 hydrogens. This has 3 hydrogens. This has 2 hydrogens. This has 2 hydrogens. You just need to complete the tetravalency of carbon. Right? Okay. So, 3, 4, 5, 6, 7, 8, 9, 10 alpha hydrogen. 10. That means you have 10 hyperconjugation structure. So, B is more stable than A. B is more stable than A. Yes, A has 10 and B has, A has 4 and B has 10. Yes, B has 10. B has 10. Very nice. Okay. Now, let us do the practice of these questions. This is A, this is B, and this is C. Identify which of the following is more stable here. These are the 3 questions A, B, C. Identify which of the following is more stable. More stable. Which of the following is more stable? So, this is the main focus point, right? This is alpha, this is alpha. Both of the alpha are sp3 hybridized. So, we can easily say this is alpha, this is alpha. Both of these are sp3 hybridized, right? So, this has 2 hydrogen, this has 1 hydrogen. So, total we have 3 hyperconjugation structure here. And from here, this is the main thing. Just wait a minute, guys. Just wait a minute. Yeah. This is the alpha, this is the alpha, and this is also alpha. Right? So we have 3 alpha carbon. This has 3 alpha hydrogen. This has 2 alpha hydrogen. This has 2 alpha hydrogen. In total, 3, 4, 5, 6, 7 hyperconjugation structure will be there. Right? Okay. Perfect. The order BCA, 3 hyperconjugation structure. Very nice. B is more stable. Very nice. Okay. So this is the main. This is alpha. This is alpha. And no. This is alpha. This is alpha. Yeah. This is also alpha. There are 3 alpha carbon present here. This alpha carbon has 1 hyperconjugation structure. This has 2 hyperconjugation structure. This also has 2 hyperconjugation structure. Total will be 2, 3, 4, 5. Total we have 5 hyperconjugation structure. The order here will be B, then you have C, then you have A. The answer is B, C, A is the correct answer. B is the most stable. B is the most stable. Very nice. B is the most stable. Very nice. Very good. So is this easy or not? Tell me. Is this a rocket science? Is this a rocket science? This is very easy. Hyperconjugation is the most easiest of all the concepts of organic chemistry. Easiest of all. Right? So, now let us come to the next one. This is A, this is B, this is C, this is D. Tell me the stability order of these 4. The stability order of these 4. Let us understand the stability order of these four. Let us understand that. Let us understand the stability order of these four. Perfect. So this is the main thing. This is alpha, this is alpha, this is alpha, this is alpha. All have 3. This has 3, this has 3, this has 3, this has 3. In total, you have 4, 3, 12 hyperconjugation structure. Understood this? Understood this Adipoli concept? Adipoli concept. Yes. Yes. Superb concept, Adipoli concept. Nice. Okay. So this is alpha, this is alpha, this is alpha. It has 3 alpha hydrogens, it has 3 alpha hydrogens, it has 3 alpha hydrogens. So in total you will have 3, 4, you have 9 hyperconjugation structure. The number of hyperconjugation structure is equal to the number of alpha hydrogens present, right? Okay. So here you have, this is alpha 3, and this is also 3, total 6 hyperconjugation structures, and this do not have any alpha carbon, so it has no hyperconjugation structure. So the answer is A, then B, C, and then D. This is the correct answer. Understood everyone? Have you understood? Understood the concept? Have you understood the concept? Is this clear to everyone? Everyone on it? Yes. Yes. Adipoli means superb. Yes. Adipoli means superb. Okay. So let us do the next. So this is a very important question. This is a very important question. Very important question. So tell me, this is A, this is B, this is C. Which is more stable? Which is more stable? Sneha, Shehna, Sharat, Sanvi, Saik. If I am pronouncing anyone's name incorrectly, I am so sorry about it. Yashwart, Angel, Kayatri. Yes. Now tell me. B, Sheikh is saying B is the most stable. Okay. Anyone else? How many hyperconjugation structure? How many hyperconjugation structure are present in A, B, and C? 666, ma'am. Trans, then cis. That means B is more stable than C. Yes, A and C are equally stable. A and C, Kevin is saying A and C are equally stable. Okay, so let us find out that. I'm so happy that you are able to find out that trans is more stable than cis. Okay, so let us find out C. All have 6 alpha hydrogen. That you have understood now? All have 6 alpha hydrogen. This is alpha, this is alpha. Okay, this has 3, this also has 3. Right? This is alpha, this is alpha, this is alpha, this is alpha. All have 6 hyperconjugation structures. So we can't differentiate this on the basis of hyperconjugation structure. We have to apply some other concept here. Let us see. Between B and C, you know that this is a trans compound. This is a trans compound. These two groups are opposite to each other. So this is a trans compound. This is a trans compound. And these two methyl groups are adjacent to each other. That means this is a cis compound. This is a cis compound. This is a cis compound. And due to steric hindrance, due to steric factors, trans is more stable than cis. Always trans is more stable than cis. Why? The reason is here there is less repulsion and in cis there is more repulsion, and that is why B is more stable than C. Now you are right about this. Now what about A? What about A? Let us find out what about A. Is A the most stable or it is the least stable? Let us find this out. Okay? Let us find this out. Now you have this thing. This is C, double bond C, and you have this is CH3, this is CH3. You can also write it as, let us draw the hyperconjugation structure of these two. This is CH3, this is CH3, this is H2, right? So for hyperconjugation structure, let's open one of these. I am opening this thing. This is H, and this is H. So this is the alpha carbon. Hydrogen attached to alpha carbon will lose its electron, right? So this hydrogen will lose its electron here, and this pi bond will be jumped here, will be jumped to this position, right? So let us draw the hyperconjugation structure. This alpha carbon this alpha hydrogen will lose its electron and will be overlapping between these two carbons, and this overlapping will be distorted here, right? Okay, so let us see, this is CH2 and this is negative because this pi bond is on this, right? So it is negative, and this is this is CH3 and this is CH2 and this is double bond. Can you see this? This is the hyperconjugation structure of this particular A. This was your A part. This is the hyperconjugation structure of A. Right? This is the hyperconjugation structure of A. Right? Now let us see the hyperconjugation structure of B or C. B or C, the linkage is same. There is only difference, but the linkage is same. The linkage of this thing, the linkage of this, and the linkage of this is same. The linkage is same. This carbon atom is attached to one methyl and one hydrogen. This is also attached to one methyl and one hydrogen. Here also this carbon is attached to one hydrogen, one methyl. This carbon is attached to one methyl, one hydrogen. So the linkage is same. So I can write it as, I can write this cis and trans as, this is CH3, this is H, this is H, this is CH3. Can I write down cis and trans like this? Can I write down cis and trans like this? Right? Okay? Yes. Wait. Have I drawn the resonance structure? Yeah. I have drawn the resonance structure. Just wait. I have drawn the resonance structure. Let me draw the hyperconjugation structure. This is the hyperconjugation. This is the one difference. Right? In resonance, this hydrogen will move somewhere, but this is the hyperconjugation structure. This hydrogen will be here. That was my mistake. This H positive will be here. Right? Yes. Thank you so much, Sheshna. This is Sehna. I'm so sorry I'm pronouncing your name wrongly. This is Sneha. Can I call you Sneha? Very difficult name. I'm not able to pronounce it. Yeah. Okay. So now let us find out the hyperconjugation structure of this. What will happen here? This is the alpha hydrogen. Right? This is the alpha carbon. So the hydrogen attached here are like this. This is the alpha carbon. So what will happen here? It will lose its electron to this, and this pi bond will be shifted here. Right? So the hyperconjugation structure will be, this is C, H, this is C, and this electrons will be here. They will be negative this side. This will be CH3, and there will be C. This is all. There will also be H. Also be CH. And this is CH2, and there will be a double bond here. Okay, these electrons have shifted on this place, right? They will be overlapping between this sigma and this vacant, vacant pi star orbital. Okay. No. This is not resonance. This is also hyperconjugation only, right? No. This is not a resonance structure. This is not a resonating structure. Resonance is not happening here. The condition for resonance is not available here. Resonance condition is double bond, single bond, and p orbital. Only then resonance occurs, right? The condition for hyperconjugation is the alpha carbon has hydrogen, and this hydrogen will lose electron. As it is losing electron, it will lose electron. They will be overlapping between these two. There will be a pi bond between these two carbons, that is here, and this pi electron will be shifted to this carbon. Right? So this is not a resonating structure. As you can see, the electrical neutrality is also maintained. This is a neutral structure. This is not a neutral. This is also a neutral structure. This positive and negative cancels each other. Right? Understood, Kevin? Understood, Kevin? The condition for hyperconjugation structure is present here. the alpha hydrogen will lose its electrons and there will be a pi bond between alpha carbon and the main carbon, and then this pi bond. Earlier in carbocation, we didn't have any pi bond there. Here we have pi bond, so this pi bond will get shifted to the next carbon. Right? Okay? Okay? Yes. Kevin, have you understood this? Understood? I'm waiting for your reply. Yes. I'm waiting for your reply. Understood or not? Where are you lost? Okay. He's not in the mood to reply or what? Okay. So guys, see, in this structure, you see, this is B or C. This is your B or C, right? In this structure, you can easily see there is a negative charge and this has plus effect. This has plus effect. And this will donate the electron. This is the electron donating group. So this will donate the electron. This negative charge. It is already negative and you are donating the electron. So this will decrease the stability. If something is already negative and you are increasing the electrons on it, so that stability will decrease. So this will be unstable because of the plus effect of CH3. But in the A structure, in the hyperconjugation structure of A, we don't see anything here, right? There is a negative charge and there is no CH3 group directly bonded to this negative charge. And that is why there is no plus effect present here. And that is why A is more stable. And this is a very important question. So that is why A is more stable, then B, then C. This is the correct order. This is the correct order. Understood, everyone? Understood? Why is the most stable? Why is more stable? Right? Understood, everyone? Understood? Yes, ma'am. A is more stable. Now, let us see another questions. This is A, this is B. This is A, this is B. Now tell me, what are the hyperconjugation, what are the number of hyperconjugation structures present here? What are the number of hyperconjugation structures present here? This is double bond, this is alpha, this is alpha, this is alpha, this is alpha. Right? This is the double bond and this is the only alpha present here. Okay, this is the only alpha present here. Now tell me, what is the number of hyperconjugation structure? It has two hydrogens. It has two hydrogens. It has two hydrogens. It has two hydrogens. So total it will be 4 hyperconjugation structures. And here you will have only one hydrogen, only one alpha hydrogen. So one hyperconjugating structure. So A is more stable than B. A is more stable than B. Right? A is more stable than B. Yes? Got it, everyone? Perfect. Perfect. Very nice. Very nice. 8 and 1. Now, can anyone please tell me, does carbon ion show any hyperconjugation structure? Carbon ion shows hyperconjugation or not? And if not, why so? What is the reason? So let us see. This is carbon, right? So carbon ion is basically a negative charge. A negative charge means it has a p orbital. It has a p orbital. It has a p orbital which is fully filled. The negative charge means the p orbital is fully filled. It has electrons in it, right? So if someone is very rich, why would we want to donate the money to that? We don't donate money to rich people. We donate money to poor people to help them, right? So carbocation was deficient. Free radical was deficient. Alkene was deficient. That is why it was showing hyperconjugation, right? By accepting the electrons from the sigma bond of adjacent carbon, right? It was accepting the electrons of the sigma bond. But here, why would Why would this donate electrons to this carbon if this is already electron rich? This is already electron rich. So that is why no hyperconjugation. No hyperconjugation. No hyperconjugation in case of carbon ion. Right? Okay? Yes. Generally, so one student is marked generally here. Why generally? What is the reason? Now, if someone is pretending to be rich, but actually they are not rich. Actually, they have some people who are taking money away from them. They are under some loan. They are under bankruptcy. They are actually very poor. So, what kind of people they are? What kind of people they are? There are people like that. What kind of people are? They are these kind of people. These kind of people. Right? So, what is happening here? There is 3 chlorine atoms in place of hydrogen. So what will happen here? These chlorine atoms are very electronegative. These are very electronegative. So because they are electronegative, what will happen? They will pull the electrons towards itself. So these electrons, these chlorine atoms will pull these electrons, the electrons of this fully filled p orbitals towards itself. Right? Because they are very clever. They will pull the electrons. Right? So what will happen here? There will be a hyperconjugation, and that hyperconjugation is called minus H hyperconjugation, negative hyperconjugation. All of the things that we have discussed before were plus H hyperconjugation. This is minus H hyperconjugation. Okay? This is hyperconjugation, minus H hyperconjugation. What are you talking about? Carbon ion will not show this effect. Am I right? Yes. Carbon ion will not show this effect. That is completely right. It will violate because this has fully filled. It is fully filled p orbitals. It already has fully filled p orbitals. Why would it want to? It is not electron deficient. So it will not accept the electrons from any sigma bond. But what will happen here? If the alpha carbon is attached to some electronegative atom, then this will pull the electron towards itself. It is going to pull the electron towards itself. It is pulling the electron. So what will happen? What will happen here? The hyperconjugation will be like this. This negative will jump here, and this chlorine will take out the electron. Right? So what will happen here? The hyperconjugation structure will be this. This is double bond. This is C. This is H. This is H. This is Cl. And this is Cl negative, and this is Cl. These are the hyperconjugation structures, right? When we are donating the electrons, that is plus H effect. As we are extracting the electron from this carbon, this is called minus H effect. This is called minus H effect. Okay? The hyperconjugation structure will be like this. The hyperconjugation structure, here we are extracting the electrons, right? So carbon ion will show this effect only when in place of hydrogen at alpha position there are electronegative atoms. Most electronegative atoms, highly electronegative atoms are attached to it. Only then it will show hyperconjugation, and that too it will be negative hyperconjugation. Okay? That too there will be negative. Hi, hello, Gopika ma'am is here. Gopika ma'am is here. She's saying again these conjuice makki chews are not liking the session. Yeah, she is saying that. She will definitely say that. Isn't it? I totally agree with her. I totally agree with her on that point. Yes. Don't disappoint her, okay? Don't disappoint her. You are her cute little student, so don't disappoint her, right? Yes. Yes. So everyone is saying good evening to Gopika ma'am. Yes. So, yes. Have you understood this? Is this clear to everyone? Carbon ion do not show hyperconjugation in general, but it does show hyperconjugation when there is a electronegative atom attached to alpha carbon, because in that case it will pull the electrons. So there is a negative charge on this carbon. It is going to shift to this, and this is pulling the electron from this carbon. Otherwise, we were donating the carbon to electron deficient carbon, donating the electrons to electron deficient carbon. Now the carbon is electron rich, and we are taking away the electrons from it. So this is minus H effect. Understood? Yes Okay? Yes, cute little students. Perfect. Yes. Okay. So now let us see. Next is this one. Now, oh my God. Such a big structure, ma'am. What to do now? What to do now? What to do now? Tell me. What are you writing? No, I can't do that to these tunumunus. Now tell me, here, you don't have any positive charge, you don't have any negative charge, you don't have any double bond, right? So what will happen here? Here is this benzene group. This is your main king. This is the king. This is the king, right? So the carbon attached to this benzene are called alpha carbon. So this is bacha. So this is so beautiful, so elegant, just looking like a wow, right? So this is alpha, this is alpha. This is also alpha, this is also alpha, this is also alpha, this is also alpha. So you have total 6 alpha carbons present here, isn't it? You have in total 6 alpha carbons present here. For these 6 alpha carbons, how many alpha hydrogens are there? So it doesn't have any alpha hydrogen, 0. Doesn't have any alpha hydrogen, 0. Now it has 2 alpha hydrogens, 2. It has 1 alpha hydrogen, 1 alpha hydrogen, and there are 2 alpha hydrogens. So in total you have 2, 3, 4, 5, 6 alpha hydrogens. Okay, so it will be 6 hyperconjugation structures. Understood? Understood this? Understood this? Students, have you understood this? Understood? Yes? Perfect. Very nice. Very nice. Very nice. Yes. Total 6 alpha hydrogen. Very nice. Total you have 6 hyperconjugation structures. Now let us see this. How many alpha hydrogens will be present here? How many alpha hydrogens will be? Is Gopika ma'am still in the session? So let us see what does Gopika ma'am answer. How many alpha hydrogens will be present here? Let us see the answer of Gopika ma'am. Okay, you also type your own answers. Okay, let us calculate the alpha hydrogens present here. Let us calculate the alpha hydrogens present here. Yes. So this is it's a honeycomb. Okay. Yeah. It looks like one. It looks like one. Most of the structures of organic chemistry looks like one. Yes, ma'am. 3. Okay, 0. 0 you are saying. So, what will be the main group here? If you consider this positive charge as the main group, right? So, this will be your alpha, right? But this is sp2. So, considering this positive charge as the main group here, you will not find any hyperconjugation structures. So, instead of this, we'll say this is our main group here, right? So, for that matter, this will be alpha. This will not be alpha because this is not sp3 hybridized, right? This carbon is not sp3 hybridized, so this will not be alpha. This is only alpha, which is sp3 hybridized, and it has 2 hydrogens attached to it. So total will be 2 hyperconjugation structures. In total, there will be 2 hyperconjugation structures. Understood? Yes. Yes. Perfect. Nice. Everyone understood this or not? How will this have 2 hyperconjugation structure? Is everyone clear on this part? Is everyone clear on this part or not? Yes, perfect. Very nice. 2 hyperconjugation structures, right? So, in that way, we are done with hyperconjugation. Now, how can we select a main group? How can we select a main group? Okay. How can there we select a main group? So guys, here if you consider this as your main group, there will be no overlapping. There is no hyperconjugation. Hyperconjugation will occur both ways, right? Hyperconjugation will occur both ways, right? So if there is no overlapping between this and this, the compound is like this, right? So there is a vacant orbital here. So if you mathematical manner, you see there is a vacant orbital here. There is a vacant orbital here, but this is sp2 hybridized, and that is why there will be no overlapping of electrons of orbitals. There will be no overlapping, and that is why we have chosen benzene, because we have alpha carbon which is sp3 hybridized, and in that way we are able to find the hyperconjugation here, right? Okay, benzene is the main group here, right? Benzene is the main group here. Main group, by main group we are saying that by considering this as the main focus point, you will be able to find the alpha carbon, right? Okay, understood? Guys, if we are taking this as the carbocation as the main group, in that case you will not be able to find any hyperconjugation. It doesn't mean, if I am considered, that is my way of finding hyperconjugation structure, to consider this. But that doesn't mean I have to select both as main groups one by one. If I am selecting this as main group, this is the alpha carbon, there is no hyperconjugation, so no hyperconjugation in that case. In the second case, I am accepting this as the main group. In this case, I can find the hyperconjugation on this part, right? That is why I am saying there will be only two hyperconjugation structures. And this will not be included because there is no alpha carbon here. For example, what if we have something like this? What if we have something like this? This is one hydrogen and this is CH3. In that case, I will choose, firstly I will choose this as the main group. This will be the alpha carbon and there are 3 alpha hydrogen. Right? I will write this 3 alpha hydrogen. Okay, this is my first case. Now, after that, there will also be a hyperconjugation here. There will also be a hyperconjugation present here. Here also there will be hyperconjugation. If I consider this as the main group, this will be the alpha carbon and it has 2 alpha hydrogen. So I'll write plus 2 alpha hydrogen. In total, it will have 5 alpha hydrogen. In total, it will have 5 hyperconjugation structure. Okay? In total, it will have 5 hyperconjugation structure. In first case, this is the alpha carbon. In second case, this is the alpha carbon. In first case, this is the main group, and after that, these are the 3 alpha hydrogen. In second case, these are the main group and this is the 2 alpha hydrogens. Understood? It depends overlapping, yes or not. Yes. Oh my God, Ravan is here. After so many days, Ravan is here. Yes. Okay. Understood this or not? Understood this? I think this is the best way to understand this. Right? This is the best way to understand this. That firstly, take this as the main group, because see, that is a way of finding the hyperconjugation structure. That is a way of finding. You can't ignore this hyperconjugation and this hyperconjugation. Hyperconjugation is happening this here also and here also. You have to calculate these 2 hyperconjugation structures. Right? So firstly, I'll calculate considering this as the main group. After that, considering this as the main group. Understood? Oh, so sweet. Thank you so much, Gopika. No one is targeting you. No one will ever target you. Yes, they all love you. Right. So guys, please wish Gopika ma'am Happy New Year. Happy New Year. Yes. Yes. Perfect. Yeah, because she's a biology teacher, right? She's not a chemistry teacher. Right? So even I won't be able to give bio or physics answers. We are only the queens of our own subjects, right? Yes. Yes. So understood this, everyone? Has everyone understood this? Yes. Yes. Understood this, guys? Tell me. Yes. Happy New Year. Happy New Year. Yes. Now, guys, tell me, have you understood this or not? Shall I move? I think this was the last question. There's no problem in this, right? Okay? Okay. So now let us move ahead. Electromeric effect. Electromeric effect. So guys, electromeric effect is another effect. So for example, electromeric effect is actually a temporary effect. It is a temporary effect. It is what? It is the temporary effect. So by considering this as temporary effect, this means that if there is a carbon double bond carbon, there is no as such partial positive or negative charge here. Now, if some reaction, some reagent is coming towards it and the reaction is going to happen, in this case, this is positive and this negative. And in this case, when it is approaching this particular carbon double bond carbon, so this will partial negative, partial positive. So this H positive will be shifting here. This H positive will be attacking here, and this negative will attack here. In that case, when a reagent is approaching, only then there will be a dispersion of electrons. So in that case, that is called electromeric effect, because it needs some outer reagent so that there can be any distortion or dispersion of electrons. Okay, so that is why it is a temporary effect. So now let us see, there are two kinds of effect, plus C and minus C. Now let us see what is plus C and what is minus C. What is plus C and what is minus C? This is plus C effect and this is minus C effect. This is minus C effect. Okay, so this is plus C, this is minus C. So for example, you have C double bond O. You have C double bond O, right? And there is the attack of H positive. There is the attack of H positive. Any electrophile, any H positive. The attack of H positive, which is electron deficient species. So now what will happen here? There will be a partial negative charge here. There will be a partial positive charge here. This H positive will attack on this species, right? This H positive will attack on this species, or I can actually write it like this. This H positive will attack on this species. This means that the electrons will be shifted here. There will be C positive, O negative, and this H positive will attack here. This means that the atom where the electrons are shifted and the atom where the reagent has attacked is the same, right? The atom where the electrons are being shifted and the atom where the reagent is attacking are the same. If that is the case, that is called plus E effect. That is called plus E effect. Okay, that is called plus E effect. Now we have another example. This is C double bond O, and now we have Cn negative, right? In this case, again there will be positive and this will be negative, right? Because of the electronegativity difference. Now what will happen here? The electrons were shifted this side, okay? But if I can write it more clearly, this will be, oh my god, this will be double bond and the electrons are getting shifted here. But the Cn negative is attacking here because this is positive and this is negative. So the electrons are shifting to a different atom and the reagent is attacking to the adjacent atom, right? So that is called minus effect, because the electrons are shifting and the atom where electrons are shifting and the site where the reagent is attacking are different, and that is why it is called minus effect. Okay, this is opposite to each other. That is called minus effect. Okay, that is called minus effect. Yes. Plus C means same and minus C means different. So guys, if you can take an example, this if there is a shifting of, let us take another example. You have C triple bond N, right? This is the compound here, right? So you know this is partially negative, this is partially positive. So the electrons will be shifting here. The electrons are shifting here. But now, if you have a positive species, and you have a negative species. So now the positive species will attack on this side and the negative species will attack on this side. Now in this case, when the positive species is attacking, the electrons are shifting to one atom and the positive species is attacking on the same atom. That is called plus C effect. That is called plus C effect. But in another case, the electron are shifting towards nitrogen. But this nucleophile is attacking on carbon. That means it is attacking on the opposite atom. So this is called minus effect. This is called minus effect. Now have you understood? Now have you understood, bacha? Shehna? Shehna, have you understood now? If the atom where the electrons are moving, the electrons are moving on this negative charge, to see how this breaks. C double bond O. This is C double bond O, right? This is partially positive, this is partially negative. So how the electrons, this pi bond, the electrons of this pi bond are shifting like this. Okay, that means there will be a positive charge here, there will be a negative charge here. This is how the electrons are shifting here. Now, if there is a positive species that will attack here, and if there is a negative species that will attack here, right? Okay. So the electrons are shifting to this oxygen atom. Plus the effect is that when the shifting of electrons and the attacking of the reagent are on the same atom, that is called plus the effect. When the shifting of electron and the attacking of reagent are on different atom or on opposite atom, that are called minus effect. Understood this? Okay, perfect. Perfect. So now let's just see. I'll just give you one question. Okay. You need to tell me how many hyperconjugation structures. How many hyperconjugation structure will be present here? Okay, this is your homework. Okay, perfect. I'll see this tomorrow if you have done your homework or not. Okay, Ji, understood? Perfect. So guys, I'll see you on Thursday. I'll update you about the time. Understood? I'll update you about the time on Telegram channel. Yeah, perfect. Okay then, see you all on Thursday, and please do your homework. And these are only the 4 months are left, and you need to put all your efforts in this 4 months so that you are able to clear your NEET exam and are able to fulfill your dreams in reality. Okay, I wish you all the very best, and just give your 100% and you will definitely see the results. Yeah? Okay then. Bye-bye. Take care. See you all. My Telegram link is the Vedantu NEET English. You can already see that. Okay, there will be all the notes and everything will be provided on the Telegram channel. Okay, bye-bye. Take care. What I have forgot? Yes, tell me. Yes, tell me, bacha, what I have forgot. Ritual, okay, there's one ritual, okay. Yes, please tell me one Malayalam word. Yes, what is the word? What is the word for today? For ma'am. Let us see what is the first word. Please give me some easy words. I'm just in the learning phase right now. Yes, I'll do that in the next session. I'll definitely do that. Okay? Yes. What is the word? Yeah, I think all the Malayalam students have left the chat now. Yes, we will definitely complete. Yes. Guys, tell us, everyone is waiting for your new word, new vocab. We want to add onto our vocab. Kazhicho. What does that mean? You please give us some easy word. Santosham. Santosham is actually easy. It's actually related to Hindi. Yeah, Santosham is easy. Happy. Okay. So now everyone on the comment section, everyone will write Santosham. Okay? Everyone will write Santosham. Yeah, please bring some easy words for me. Okay? Okay, please bring some easy words for me. So now after this session, you all are feeling Santosham. Santosham. Yeah. But I am from Punjab and Punjabi is somewhat related to Hindi only. So I don't have much knowledge, but I'm very eager and enthusiastic of learning. Even my students from North are very eager to learn languages of your state. We are very excited for that. Yes, Santosham. Santosham. Am I pronouncing this correctly? Am I pronouncing this correctly? Okay. Okay. Got it. Got it, Srinath. Got it, Srinath. Perfect. Nice. So the word for today is Santosham. So everyone on the comment section will write down Santosham. We are feeling Santosham after the lecture. Okay. Bye-bye. Take care. See you all day after tomorrow for the session. Bye-bye. Take care.